Debra Seifert. Here's a look back on the International Microwave Symposium of 2016. So follow me around the show as I drop in to interview exhibitors about the leaps forward in microwave and RF technologies.
Show's been great this year. We've been really impressed with the traffic. For a reduced footprint of the show, we're really impressed. I think it really did a good job. San Francisco's great. It's close to the Bay Area, close to our customers. We're showing great things, and we're really happy.
The interest in our products has been through the roof. It's been terrific.
And what do your products do?
We have a line of USB-powered electronic test equipment. We do signal generators, digital attenuators, phase shifters, RF switch products, anywhere from up to 20 gigahertz in our product lines.
Hi, my name is Alejandro Buritica, Senior Product Marketing Manager with National Instruments, and today we're demonstrating our 802.11ax test solution. This is the next evolution of the Wi-Fi standard to fit more users in dense environments and be able to serve them with higher throughput.
Well, my name is Matt Del Margo, and I'm an applications engineer with Keysight Technologies, and I'm really enjoying this show. This is my first IMS I've ever been to. I've heard many, many things about them before, but I've never had a chance to come. So I'm excited to be here, and I'm excited to be a participant.
We build radar test systems, and most recently we've developed a new series of test systems, the 1100 series, that offers the designer and the radar system test engineer the ability to create full simulations of moving targets that they can use to test the system either in the laboratory or on the test range itself.
So IMS 2016 has been absolutely incredible for us. Once again, the premier show in the RF and microwave space. MACOM specifically, booth 939, has been showcasing GaN technology, the latest and greatest in wireless communications, RF energy, as well as RF power for L-band and S-band A&D applications as well.
So my name is Jarrett Latter. I'm out of Analog Devices out of Greensboro, North Carolina, with aerospace and defense in particular. So I've been coming to this show for well over 10 years, and here's what I've seen. This is started out, in my point of view, as more of a handset type of trade show. Had some semiconductor guys here, some hardware guys, but if you were to look around today, this is an amazing show. Again, I'm in aerospace defense. We've got defense contractors, we've got handset guys still, we've got space applications here. This show has grown from something that was small and up and coming to a major show. This is one of the largest shows that Analog Devices does every year, and we really try to pay attention and to the effect that we bring actual applications and design engineers to do demos to show our hardware, not just individual components, but we put the hardware together and make entire systems. So we really try to make a big effort because this show has grown to be such an attractive event for us.
Hi, my name is Tom Valencia. I'm an application manager at Skyworks. And today I'd like to demo our newest power amplifiers for small cell application. We have the Sky 66184-11. This is for small cell application with an output power of 23 dBm. What we're trying to demo here is that our PA can survive and operate very well at the harshest conditions, up to 85 degrees. So we're heating the part up at the 85 degrees, and we're measuring the ACLR performance with a 10 megahertz LTE signal. And we're getting about minus 48 dBc with a 10 megahertz signal at 23 dBm.
My name is Rich Piechek. I'm a product manager for Roden Schwartz, based in Columbia, Maryland. I handle specifically the spectrum analyzer products, and here we're highlighting at IMS this year a number of our handheld offerings that are currently available. Handheld digital oscilloscope. Next to it we have a Spectrum Rider FPH handheld spectrum analyzer. Goes to 2 gigahertz with options up to 3 or 4 gigahertz. It's a touchscreen controlled spectrum analyzer, making it very easy to add limit lines, put markers up, and very easy control of the instrument. Next to it is our FSH platform family. This particular instrument has frequency ranges that go up to 20 gigahertz and offers demodulation capability, whereas the FPH is strictly spectrum measurements. The FSH family adds to the spectrum measurements and offers demodulation capabilities for many of the current popular wireless standards.
So I'm Steve Reyes, product manager at Enritsu Company. And so what we're showing is the Vector Star performing modulated measurements. And the idea is to give the PA design engineer the ability to characterize their amplifiers under real-world modulated conditions. And usually what you'll find in a VNA is the ability to characterize the amplifier in CW, so you can very accurately gauge the nonlinear properties of the amplifier under CW conditions, and take a look at IM products, etc. So you get very accurate IMD measurements as well as gain compression measurements using CW signals. And so people will design their amplifiers under those models, and then they'll put it into a digitally modulated communication system where the carrier frequency is modulated by amplitude over a broad range of possible modulation rates.
It's been so far 2 excellent days, and we've got a lot of interest in all of our products, but a few special highlights include what we've done in low temperature coal-fired ceramic, which is pushing our frequencies higher and up to 20 gigahertz, along with our semiconductor products, both our packaged MMICs, which include amplifiers up to 26 gigahertz, low noise, high dynamic range, some of our feature products, which have been featured in a number of magazines, including the PMA3 83LN, which is right now the industry's lowest noise, broadest band amplifier from 0.5 to 8 gigahertz.
What we've got in front of us here is a 4-port system. This is part of one of our wafer level measurement solutions that we have. This 4-port system allows us to make measurements up to 110 gigahertz, and we're using a system from our channel partners, Keysight Technologies, which is a 4-port combined system, single sweep, so you can go all the way from 10 megahertz to 110 gigahertz in 4 ports.
I'm Mark Ashcroft. I'm with Pico Technology Limited. I'm the RF Business Development Manager. The modern sampling oscilloscope probably represents your lowest cost alternative for visualizing, measuring, for characterizing your microwave, your RF, or your gigabit signals. That's because within a sampling oscilloscope, the extent of RF and microwave circuitry, well, it probably only occupies half of this relatively small footprint instrument.
It's been going great today, and I would say with IMS, it's just a very vibrant, energetic show. And what we've done at our exhibit is we're showcasing 3 clusters. We've done some new announcements. And so if you think about it with the GaN cellular products, we're expanding into that technology. So we have both the LDMOS technology and now many more GaN products that we've introduced. Another announcement that we've had at our event is the outdoor small cells portfolio. So that's inclusive of about 8 products that we've announced. And so this can bridge the gap of where there may not be the most robust coverage. So if you think of like stadiums and athletic venues, shopping malls, things like that, this can help to cover that gap in coverage and make sure people get the data that they want when they want it.
Good morning, I'm Guillaume Di Giovanni from NoiseXT, and I'm going to talk to you about 2 products. The phase noise analyzer called NXA and the signal generator called SLC. Another feature that's very interesting is when things go bad, when you're testing a DUT and it's not working right. You want to know why do I have so much phase noise? Then you can look at the time domain and you can see any transient that happens in the phase noise that would give you too high phase noise, but you need to know why, because you need to fix the DUT. So by looking at this, you can see transients and then have a better understanding of what's causing the problem in the system. 2017 is the IMS year, because it's going to be in Hawaii. And what do we do in Hawaii besides showing high technological stuff? We surf and we play with dolphins. So next year I want everyone to come to IMS 2017 because I'll be there and I want to learn how to surf.